Let's take a look at this probability distribution problem. It's problem 5.12. Suppose that the probability distribution of a random variable x can be described by the formula. We see the probability of x is equal to x over 15. For each of the values, x equals 1, 2, 3, 4, and 5. For example, the probability of x equals 2 and the probability of 2 equals 2 over 15. So, first, under part A, we need to write out the probability distribution of x. And this is what it would look like. Slide this down so you can see it. Okay, that's it. So if you were to solve for this, what you would get is the probability of x would be 1/15th, then 2/15ths, right? Then 3/15ths, which reduces to 1/5, 4/15ths, and 1/3. Okay, that's what they're looking for part A. Part B says, show that the probability distribution of x satisfies the properties of a discrete probability distribution. All right, so how we could show that is given right here. All right, so what do we see? We see that the sum of the probability, all the probabilities for x, is equal to 1/15th plus 2/15th plus 1/5 plus 4/15th plus 1/3. And the point of this is that if you were to add all of those up, it equals 1. Now you could reduce the fractions, right? Or you could turn them into decimals and add those up. But the test to see whether it satisfies the properties of a discrete probability distribution is that it equals 1, and it did. Now part C says calculate the mean of x. Well, how we would calculate the mean is we would take and use this formula to derive the mean. So what you see is we multiply 1, where the variable x is equal to 1, times the probability of x. Then we add in 2 times the probability of x when x is 2, and so forth. And when you're done, we've got a mean of 3.667. Next, part D says calculate the variance and the standard deviation. Okay, now mathematically it's going to look like this. Let me slide up so you can see more of that. Okay, so the variance is going to be equal minus 3/6, looks like repeating, squared, times 1/15, and then we multiply again that mean times the next value till we go to the end and come up with 1.556. And then we take the square root of that and we can come up with the standard deviation. Okay, now what I want to do is illustrate the calculations of C and D if you were to do it using Excel to help you with the calculations. And what I also did is added in some of the formulas we need. So the mean or expected value of a discrete random variable is given in this formula right here. You take the sum of x times the probability of x for all x. Okay? And the variance then is the sum of x minus the mean or expected value squared times the probability of x. Okay? And then the standard deviation, take the square root of the variance. All right, now down below, what you can see here is I've jotted in x, 1 through 5, and the probability, or not the probability, that's right, the probability distribution of x. So we had 1/15, 2/15, 1/5, 4/15, and 1/3. Okay, we calculated that under A. All right, then what we would do is we would multiply x times the probability of x and sum it to come up with the expected value or the mean. So I worked this ahead of time. Let me bring this to light and you see what I did. Okay, if we hit the F2, we take the value in cell C30 times C31. You can also look up here, right, and see it. And we come up with a value. Then we just copy that across, right? And it's simply multiplying the x times the probability of x and sum it. So here's my sum of that, and we come up with a mean of 3.667. All right, let me slide down a little bit. Then if you wanted to calculate the variance, now the calculation gets a little bit hairy, but I'll work you through it. You would take what's in C30, that's x, I'm sorry, C30, yeah, C30 is x, times the mean, and that's in H32, and I put dollar signs around it so that when I copy it, it is a permanent value of cell H32. Then we square it, and then multiply it times the probability of x. So all we're doing is working this formula except for the summation. And if I copy that over for all 5, you'll see it'll all work. You know, take the value of x times the mean squared. There's my squared symbol right there, times the probability of x for this particular discrete variable, 1/3. And we get that. And of course, if we copy this, we can sum it, and we come up with 1.556, which is the variance. And then to calculate the standard variance, I'll slide down one more time and bring this to light. And all you're doing here is taking the variance and taking the square root of it. So you can take that to a power of 1/2, or you could use Excel's square root feature. You hit square root and then point to where the cell is, close it out, and you're going to get that same 1.2472, and I think in the calculation by hand they came up with 1.2474, and that only has to do with rounding of decimal places. But that's how you would calculate it. I'm going to say by hand, but I'm using Excel as a template, and then of course I'm relying on Excel to calculate the standard variance for us.